Okay, number 27 wants the equation of the tangent line to this curve right here when t is equal to 2. So again, I'm going to do the easy part first. We're going to find s of 2 to get our point of tangency. So that's going to be a 3 to the 9 times 2 power, 3 to the 18th. Now everybody, I'm a pretty smart guy. I do not, unfortunately, know the value of 3 to the 18th, but I'm guessing that it's really, really, really big, so I don't care. I'm going to leave it as 3 to the 18th, and that's going to tell me that my point of tangency is going to be the ordered pair 2 and then 3 to the 18th power. So, okay, we'll just leave it right there and say, all right, that is probably good enough for that. Now, on to the fun part. We got to find our derivative to eventually get the slope of our tangent. So s prime of t, here we go. We've got a number raised to a power. So that derivative is going to be the same base, 3, to the same power, 9t, multiplied by the derivative of that exponent, which is 9, and then multiplied by the natural log of the base of that exponent, which is 3. Now, something interesting happened right here, and I haven't looked at the solutions manual yet to see if they took advantage of this or not, but rather than just rewriting this as maybe what, I don't know, 9, no, that's not what I said, here we go. You could just rewrite this as 9 times the natural log of 3 multiplied by 3 to the 9t power, but what's interesting right here, I want to try to run with this for a second, is the fact that 9 is 3 squared. And if you look at what's going on right here, guys, we're multiplying 3 to a power multiplied by 3 to another power. So if you guys think about what happens when we take, let's look down on the bottom here, something like x squared multiplied by x cubed, pretty much all of us are going to look at that and go, oh yeah, the answer is that it simplifies to x to the 5th. You can add those exponents together, and that means that we could have rewritten this right here as maybe the natural log of 3 multiplied by 3, and then we would add the powers together, 9t and 2. They don't combine, but they can be added. That, I think, is maybe a little bit nicer of a way of writing that s prime of t right there than the way I had it written before. You know what, though? I'm probably worrying about this more than I need to, because we're not just looking for s prime of t. We want s prime at this value right here, s prime of 2, so that might be kind of a moot point what I just did. Natural log of 3 multiplied by 3 to the, let's see, 9 times 2 would be 18. Oh my gosh, plus 2 would be 3 to the 20th power right there. And if I wasn't going to evaluate 3 to the 18th before, I am certainly not going to evaluate 3 to the 20th. I'm going to call that good. So that right there, guys, is the slope of our tangent line. So here was the point of tangency. Here, it's ugly, but that's it, is the slope of our tangent. So let's go ahead now. I'm going to switch to purple right here. All right, and let's do what we can do in point slope form for now, guys. Y minus the y-coordinate of your point of tangency, 3 to the 18th, equals the slope of your tangent, which is the natural log of 3 multiplied by 3 to the 20th, and then in parentheses, x minus the x-coordinate at your point of tangency, which is a 2. So there's the equation in point slope form, and what the book tends to do with problems like this where the slope is so god-awful ugly that distributing it would still make an absolute mess, they tend to give up on that and say, okay, we're just going to take this k value here and bring it to the end. So what I'll bet they have in the solutions manual is this. Y equals the natural log of 3 times 3 to the 20th multiplied by the binomial quantity x minus 2, and then just a plus 3 to the 18th at the end of all that. Now, I suppose you could have factored out a 3 to the 18th, but I kind of doubt they did that on number 20. Yeah, they did not. So they left it more or less the same way we'd have it here, guys. They took these two factors and changed the order, but other than that, they have the same thing that we have. So that is good enough for us for number 27.